Hello, my name is Robert Smith and I'm with New River Community College, and today we're looking at just how to predict whether a reaction will yield a change in entropy that is positive, meaning that entropy is increasing in the system, or negative, meaning that entropy is decreasing in the system. So I have three short examples here. The first is calcium carbonate dissoluting to calcium oxide and carbon dioxide. So for here, there's a couple of things that indicate to us that the entropy overall is increasing. The first being that we're going from 0 moles of gas on the left-hand side to 1 mole of gas in the form of carbon dioxide on the right-hand side. So that's one indication. The next indication that you can also look at is the fact that you have a solid turning into another solid and a gas. So you have this system where at least part of it is getting turned into a phase of matter that has a greater number of microstates. And as a result, we can say that the delta S for this reaction at standard state is going to be positive, meaning that it's greater than 0. So for the next one, we have diatomic nitrogen plus diatomic hydrogen yields 2 moles of ammonia. The number of moles on the left-hand side of gas are 1, because there's an implied 1 in front of there, plus 3. So the moles on the left-hand side are 4 total versus only 2 on the right-hand side. So the moles of gas are decreasing in this reaction as it is written. The other thing you want to think about are the number of species involved in general are decreasing. You go from having 2 species in this synthesis reaction to 1 species as the product. So the number of species is decreasing. So we can say that our change in entropy at standard state is negative, meaning that entropy is going down by having this synthesis reaction. Last case, we have again hydrogen, but this time we're adding chlorine and we're yielding hydrochloric acid, but in the gaseous phase rather. So the moles are the same. You have 2 moles of gas on the right-hand side and 2 moles of gas on the left-hand side. So that doesn't change much. What we can look at now, the least prioritized form in our change of entropy is the complexity of the system. So if you have 2 hydrogens that are bonded together or 2 chlorines that are bonded together, they're homogeneous. They don't really have too many entropic properties to them. However, this difference in hydrogen and chlorine creates, you could view it as sort of an imbalance. You have all the electrons getting collected around chlorine, very few around hydrogen. In general, the number of microstates are increasing because you have more opportunities to create change in it, through that imbalance. And as a result, you can expect that delta S of the reaction is going to be positive. So it's greater than 0. And you can also expect that it's fairly small in this case. You probably won't have too much of a change in your entropy just by making it so that the hydrogens are bonded with the chlorines rather than with themselves. And similarly, the chlorines are no longer bonded with themselves, they're bonded with hydrogens. So your change in entropy will likely be very small, relatively speaking. Whereas with the previous ones, with like the synthesis of ammonia, you can expect the magnitude of entropy to be much larger compared with with the hydrochloric acid. Although the signs will be different because the number of moles on the second problem where you form ammonia have decreased as you synthesized ammonia from nitrogen and hydrogen versus the synthesis of hydrochloric gas, um, hydrogen chloride gas, the number of moles do not change. So